Good morning, this is your Stat Sensei, Mr. Spensei, and this is Rolling Down the River, which is going to introduce different types of surveys. All right, and sampling. So here's our scenario. A farmer has just cleared a new field for corn that is divided into 99 plots. And if we look down here, we go, oh, 1, 2, 3, 4, up to 11, all the way down to 99. The plot numbers are not in bold. So those were the 1, 2, 3, 4. Those are the plot numbers. There's a unique plot of land in that a river runs along one side, and there we see the river. We also see a house on the other side. The corn yield looks good in some areas of the field, but not in others. The corn yield is in bold. All right, so I'm going to mark that real quickly. The corn yield is in bold. So we have a yield of 6, a yield of 13, yield of 97 over here, and a yield of 94. Here we have a yield of 9. So the bold numbers with the Y are the yield, and the plot numbers are not in bold. Plot numbers are not in bold. Super important to know that because there is a lot of numbers on this. So the farmer is not sure that harvesting the field is worth the expense. He's decided to harvest between 9 and 11 plots and use this information to estimate the total yield. So basically, instead of harvesting all 99 plots and going, gosh, was it worth the expense? He's going to do somewhere between 9 and 11 to make a determination as to whether or not he was going should whether or not he or should harvest the entire field. So, convenience sample. First off, let's keep in mind that a convenience sample has no randomization, and you do what's easy. Well, if I'm the farmer, I think I'm probably going to leave the house, and what's going to be easy or convenient is to survey the ones closest to the house. And that's what he does. The farmer chose the 9 plots all in a row that were closest to his house because it was convenient. Mark the 9 plots. Well, here's the 9 plots. It's all highlighted. That's what he chose. And then we need to calculate what the yield was. Well, in this case, I sit there, I have a yield of 6, a yield of 7. I'm circling the yield numbers. So those are my yield numbers, and I'm going to just plug them into the calculator. Now, there's several ways to do this, and I'm going to do this in a way you haven't seen before. And hopefully this calculator, you can see it. Let's see if I can adjust that just a little bit. That might help a little bit. I don't know. We can press the stat button right here, edit, and the first number was a 6. The next number was a 7, a 2, an 8, a 4, a 5, a 7, a 3, a 9. And I should have 9 numbers in, and I do. Now I'm going to press the stat button again, arrow one space over to calc, and it should say L1 at the top. If it doesn't say L1, press the blue button followed by the number 1. And that's the average, but what I'm looking for is the sum, which is 51. And sure enough, we get a yield, a total yield of those 9 plots of 51. Or we could have just gone 6 plus 7 plus 2 plus 8 plus 4 plus 5 plus 7 plus 3 plus 9. But I make so many mistakes, I like to have a list and go, hey, did I put those in right? Because I can sit there and see the list pretty easily. Okay, the next thing is we're going to do a simple random sample. So in a simple random sample, we're going to basically put all 99 plots in a bag and mix. All right, we're going to numbers 1 to 99. So numbers 1 to 99 and mix. Well, instead of putting the numbers 1 to 99 in a bag and mix, we're going to use a random number generator on a calculator. Now, please keep in mind, your numbers and my numbers are not going to be the same. All right, the answers are going to vary. But here's the way you put it in the calculator. You're going to press the math button, arrow over to the word probability, and then drop down to number 8, which is random integer with no repeats. Press enter. Now, the smallest number, well, what's my lowest plot number? my lowest plot number is a 1, and my highest plot number is a 99. So I'm going to put my lower bound as 1. My upper bound is 99. Now the question is how many numbers am I selecting? Oh, it says I'm supposed to circle 10 plots. So that means my n, or my sample size, needs to be 10. Oops. Let me do that again. So math, probability, random integer, 1 to 99, 10. And it gives me a list of 10 numbers. And we see that we have plot number 80, plot number 95, etc. Well, I've previously done that, and I chose plot. I got plot number, and I'm going to circle the plot numbers in blue. So those are the plot numbers. Well, that's all well and good. That's what the calculator gave me. So I highlighted those. But what I really need, and by the way, I should mark out this 1 because it didn't give me a 1. All right. So it gave me 5, 15, 34, 20, 41, etc. Those are the random numbers it selected. Well, what I really care about and what I'm going to need to enter into the calculator are the yield numbers. So I'm circling the yield numbers in red. And I'm going to go back and I'm going to show you how I did this. I'm going to press Stat, Edit's highlighted. I'm going to go press the up button, so the L1, and then press, there it is, the clear button. And that clears it out. Now I'm going to start entering that data. So I have 38, enter, 28, enter, 73, enter. Then I have an 8 to enter, a 65 to enter, a 50 to enter, a 60 to enter, a 16 to enter, a 44 to enter, and a 94 to enter. So stat calc one var stats. And I ended up with 476. So the yield from the random sample was 476. All right. So there's my yield for those 10 plots. And I'm going to go ahead and put a 9 here because this was 9 plots and this was a 10 for 10 plots. All right. Just to remind myself. And by the way, this is going to be a long video, so I'm going to break it into 2 parts. The first part will be collecting the data. The second part will be answering the questions that come with it. All right, so that's a simple random sample. So the next thing we're going to do is we're going to move on to the systematic sample. Well, in a systematic sample, we're looking for every nth. All right, we're going to randomly select the first. Random select first, and then the nth. So in this case, use a random number generator to select a number between 1 and 9. Well, we're only going to select one number. All right. Now I'm going to show you how to do that. We're going to go to press the math button again, arrow over to probability. We want random integer, no repeats, and we select a number between 1 and 9, and we only want one number. In this case, I got number 3. Well, when I actually did it, I got number 8. All right, so when I actually did it, I got plot number 8 as opposed to plot number 3. I got plot number 8, and I have to add every 10th one, so every nth one. So I'm looking for 8 plus 10, which is 18. All right, I'm going to add 10 to that, and I get 28, and then 38, and 48, etc. So those are the plot numbers I'm going to be looking at. And here we see that I've highlighted those. Add 10, I got 18, 28, 38, 48, 58, 68, 78. And then I have plot number 78 plus 10 is 88, and then I have 98. And I should have 10 plots, and sure enough, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, What we care about are the yield numbers. So here are the yield numbers. And if I press the stat edit button, stat, edit's highlighted, press enter, arrow up, and then press the clear button. Now we can go ahead and enter our yield numbers. So we have a 69, we have a 56, we have a 50, we have a 32, we have a 24, we have a 19, we have a 14, we have a 3. We also have a 92 and an 80. So stat, calc, one variable statistics, and we're looking for the second number. That's the average, 43.9, but our actual total was 439. That little symbol just means to add up all the x's. It's the sum of the x's. Let's see if we can. There we go. That looks a lot better. So 439, and we had 10 plots. So I'm going to put a /10 to remind us it was 10 plots that we're taking. All right. So now we're on to the stratified sample. Well, first off, let's remind ourselves stratified is broken down on a common characteristic. So in this case, the common characteristic is how close you are to the river. This group represents one strata because it's the closest to the river. This represents another strata because it's farthest away. And then we just broke them down into multiple strata. So we broke it down into 11 strata. Now, with a stratified sample, we're going to go to each strata, and I'm going to say, call this a group. So we go to this group, and this group, and this group, and this group, and we randomly select from the group. Well, how many numbers are in the group? Well, let's count them out. If I look at the side, I have 1, and I should 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, I have 9 in each strata. So basically, I'm going to go stat, press the math button, arrow over to probability, number 8, and 1 to 9. And I only want to select one number. So we're going to scratch this out right here and just say, hey, we're going to select one number. And in my case, right now, I just got plot number 3, but really when I did it the first time, I got plot number 9. Well, plot number 9, I look for the blue. Oh, that's this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the next time I did it, I came back over here. I did the same thing. I pressed enter and it go, oh, you got plot number 1. And apparently I got plot number 1 again. And then I got plot number 5. And then I got plot number 8. Then I got plot number 9, plot number 3, plot number 2, plot number 1. We've gotten 3 ones. That's amazing. And then I did it again. And once again, all I'm doing is just pressing enter. All right. I kept doing it. And ultimately, I got a plot 7. All right. Now, if you notice, when we did this, surprisingly, we didn't get a 6 and we didn't get a 4, but really, we randomly got everything else. So that's pretty good. So hopefully this is a pretty representative sample. All right, so we have the plot numbers, but what we really care about are the yield numbers because that's what we're going to have to add up, is we're going to have to add up all those yields. So let's do that. So, oh, I should slow down. Press clear. I'm going to press the stat button. I have edit, press enter. Go up, press clear. Press arrow up, press clear, and enter. Now let's go ahead and enter those. So the first one I have was 9. Then I have a 13. Then I have an 18. Then I have a 24. Then I have a 39. Then I have a 44. Then I have a 50. Oops. 39, enter. 44, enter. 50, enter. And by the way, your answers are going to vary from mine. Then I have a 62, enter, a 73, enter, an 82, enter, and a 90, enter. And I should have entered 11. And so this is the 12th one, so I don't have a 12th one. And I'm going to press Stat, Calc, one variable statistic, press Enter. This should be L1. If it's not, press blue 1. And I have an average of 45.818 and a summation of 504. So I have 504, but I want to remind myself that this was a sample size of 11. All right, so that's the stratified. We went to each group, go to each group, and randomly select. All right, the next one, the cluster sample. Okay, with the cluster sample, we're going to randomly select a group which we call a cluster, and survey all. All right. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 clusters. We're going to randomly select a cluster, and then we're going to survey all in that cluster. So I'm going to go to my calculator. Second quit, press clear, press the math button, probability, random integer, number 8, 1 to 9, and we're going to select one number. In this case, I got number 3. Well, actually, when I did it, I got cluster number 2. So I randomly selected this, and so these are the plot numbers, once again, but this is what I randomly selected from the calculator. So it gave me these plot numbers. But once again, knowing the plot number just tells me what I need to get the yield from, and the yields is what I really need to enter into the calculator. All right, let's also talk about the cluster. If you notice, the cluster, every single one of them, every single cluster has something close to the house and something close to the river. Cluster 3, something close to the house, something close to the river. Cluster 4, something close to the house, something close to the river. So a cluster sample, each cluster looks like the population. All right. In a stratified sample, which happens to be my personal favorite, the strata do not look like the population, because this only has the ones close to the house. It doesn't have close to the river. This close to the river, but nothing else. Why do I like it? Well, because I'm insured to having some close to the house and some close to the river by using a stratified. So I make sure that every single group is represented. So stratified makes sure every single group is represented. A cluster, every cluster should look like the population, so it should be a good method some of the time as well. So we have 11 plots that we circled. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And when we put our yield numbers in, second quit, clear the calculator, I'm going to press Stat, Edit, arrow up, press clear, and I have 7, enter, 15, enter, 21, enter, 28, enter, 37, enter. And then I also have a 43. Then I have 56, enter, 63, enter, 73, enter, 81, enter, 93, enter. Stat calc, one variable statistics. And I have an average 47, but a total of 517. So I ended up with 517. I'm going to write that down here, 517, and a group size of 11. All right, so that was a cluster sample. That's gone through all of the different types. We started off with a convenient sample, and with the convenient sample, there was no randomization. We just did what was convenient. to get the data, and I was close to the house, so we don't have anything close to the river represented. We did a random sample, where we had all 99 plots included in the random number generator. We did a systematic sample. We randomly selected the first one, and then we selected every nth one, in this case, every 10th one. So we randomly selected 8, then 8 plus 10 is 18, plus 10, etc. So we're adding the same amount all the way up. Stratified, we broke it into groups or strata based on how close they are to the river. So this was really close. This one was really far away. And we just broke them up into columns based on how far they were to the river. And then a cluster, we broke them up into groups so that each group had some close to the river and some really far away, and then we randomly selected the cluster. All right, hope that helped. Look forward to seeing you on the next one when we go through the solutions.